Good morning everyone. Last time we did ozonolysis. Today we are going to discuss a very important reactions like hydroboration, oxidation and oxymercuration and demercuration. So let's start with the oxymercuration, demercuration. So look at the reagent here. Reagent is HgOAc twice H2O and NaBH4. And the key point is it is anti-addition, Marconi-Cops rule, and the last point is the intermediate is not a carbocation, it's a mercurinium ion. So how we can figure out what is the key point of this reaction by looking the reagent. So look at here, mercuration, mer sounds like Marconi-Cops, okay. So we all knew what is Marconi-Cops, and look at the reagent here, H2O. So it is quite simple. It is a addition of water according to Marconi-Cops rule. Clear? This is the nucleophile H2O. And the second point is anti-addition. So look at the NaBH4. Just look at this Na. We can say this one as An as well, am I right? An, just reverse it, An. So it sounds like NT. Okay, this is anti-addition. So we can correlate these things. So, and this reagent is called, what is the name of this reaction? Look at this, this is a mercury. So that's why we can say mercuration, okay. And mer means Marconi-Cops, Na sounds like NT. So this is anti-addition, Marconi-Cops, and mercurinium ion is a intermediate. So you can see mercury. So mercurinium is a intermediate. So let's discuss the reaction of it. Suppose we have this reaction, clear? And H2O is a nucleophile. So in H2O, the OH minus is a negative part. So what is Marconi-Cops rule? According to the Marconi-Cops, negative part will attack on the carbon which is more substituted. So this carbon is more substituted. So OH will be here. Suppose, let's talk about the stereochemistry. Suppose this methyl on the wedge. So this OH on the dash, clear? And the reaction is anti-addition. So anti means this OH minus and H plus. So this OH and H plus will be anti to each other. So you can see OH is here dash. So wedge will be a hydrogen. Clear? There is a one more possibility. Suppose OH on the wedge. It means this methyl will be dash. And then hydrogen will be dash. Clear? So you can see NT means this OH and H plus have opposite stereochemistry. Clear? One is a wedge, one is a dash, like this. I think it's quite simple. Three things you must have to know. First, Marconi-Cops addition. Second, anti-addition, and intermediate is mercurinium ion. Clear? Now the next is hydroboration oxidation. And the reagent is BH3, H2O2, OH ion and H2O. OH ion, so this is a nucleophile. Look at here, H2O2 is structured like this. This is H2O2 bonding. And look at this connectivity. This is peroxy linkage. Peroxy. Whenever we have a peroxy linkage, most of the time the reaction is anti-Marconi-Cops. Anti-Marconi-Cops rule. Clear? We have to apply anti-Marconi-Cops rule. So this is anti-Marconi-Cops. Again, no carbocations, no rearrangement. Clear? And this reaction, the hydroboration and oxymercuration, they are quite similar in nature. Okay, one is a Marconi-Cops, second one is a anti-Marconi-Cops. One is a syn addition, another one is a anti-addition. So if oxymercuration was NT, then it will be syn addition. Clear? This is syn addition. So let's discuss an example. So OH ion is my nucleophile. H2O2 means anti-Markovnikovs. Clear? So the product will be what? And syn addition as well. Look at, if suppose my methyl on the wedge, so OH on the dash and hydrogen will be dash as well. Clear? There is another possibility. If methyl on the dash, it means OH will be wedge and then hydrogen will be wedge as well. So this is a syn addition of this OH and H. You can see they have the same stereochemistry. So hydroboration, oxidation and oxymercuration, demercuration have similar properties with a few difference. Okay. Let's discuss few example. Suppose we have this alkene and we discussed ozonolysis as well, okay, and we discussed epoxidation as well in the last few sessions. So I am going to use all this. So the very first one is, suppose here we are using BH3, H2O2, OH ion and H2O. This is unknown product A. Again this alkene is treated with O3, zinc H2O. This is unknown B. And again this alkene is treated with HgOAc whole twice. H2O, NaBH4. Clear? And you must have to know what is the name of all these reactions. Clear? So let's start with this one. This is O3 zinc H2O. This is a reductive ozonolysis. Reductive ozonolysis. Quite simple. Break the double bond carbon and just attach oxygen on both sides like this. Here oxygen, here oxygen. So you can see this carbon has a double bond O. And this carbon also has double bond O with 2 hydrogen. Clear? So this is the structure of B. This is hydroboration oxidation. In short, you can say this one as HBO, hydroboration oxidation. And H2O2, anti-Markovnikov. OH is a nucleophile. Clear? We are not going to use here stereochemistry. So simply you can say anti-Markovnikov, it means OH attack on the carbon which is less substituted. So here. And the top one, this one, oxymercuration, demercuration. In short, you can say this is OMDM, oxymercuration, demercuration, OMDM. And this is what? Markovnikov's mercuration. Okay, Markovnikov's. OH is my nucleophile and anti-addition, but we are not going to use stereochemistry here, and the product will be what? Here. Clear? So this is hydroboration, oxidation, ozonolysis and OMDM. Clear? So in the next session we will cover few more reactions. Thank you so much for watching this.